Good morning. All right, so like I told you before, today we're going to review for the test that'll be posted as soon as we come back from the break. So again, don't forget that we do have homework that's due midnight, if I'm not mistaken. Just double check that due date. Yeah, so the 3.5 to 3.7 stuff is due by midnight tonight, so make sure you get that done before the break. And then as soon as we come back on Wednesday of next week, then I'll post the actual test Wednesday midnight, and it'll be due Friday midnight when we come back. Okay. Any questions, comments, concerns now before we get started on the review? Okay, and so just so you know, I will be working over the weekend and also Monday and Tuesday of next week. So if you are working on the practice test or have questions about anything, feel free to ask, right? And send me an email if you need to. I won't have student hours like normal student hours or anything those 2 days, but I will at least be answering email and stuff. So if you need to ask me a question, feel free. Okay. All right, so let's take a look here at number one. We want to express this in standard form, right? And remember, another name for standard form is vertex form. So when you see this now, just know that we're trying to find the vertex form of that quadratic. So what would be our first step here if we want to get this equation in vertex form? Okay, good. So let's move the 3 to the other side. And if you want to rearrange the terms first also, feel free to do that. Let me go ahead and put those in that order. So this will be negative 8x squared plus 24x plus 3. And like you said, we're going to move the 3 over. I'm going to change f of x to a y just so I don't have to write f of x over and over again. We'll say y minus 3 equals negative 8x squared plus 24x now. Okay. Now, what's our next step to get this into vertex form? Okay, that's going to be a step, but before we can do the b divided by 2 squared and complete the square, what do we have to remember to do first? That's right, we have to factor out that negative 8. So anytime there's a value in front of the x squared, make sure you factor that out first. I'm going to keep my y minus 3 over here. I'm going to factor out a negative 8, which is going to leave us with x squared, and then this becomes minus 3x. Okay, so now we can complete the square, right? I'm looking for what value I'd have to put in here to do that. Now we can use that b divided by 2 squared. What's my b value this time? Negative 3. Good. So we're going to take negative 3 divided by 2 squared. Well, what's negative 3 divided by 2 squared going to give us? Good. So we square the negative 3, that's positive 9. Square the 2, that's going to give us 4. Okay, so 9/4 is our new c value now. So I'm going to put plus 9 over 4 in here. Now, if I do that, what else do I have to remember to do now? Whatever we do to one side, we have to do to the other side. So what am I actually putting on the other side now? That's right. It's 9/4 times the negative 8, right? Because remember, this negative 8 would actually get distributed to that 9/4. So what do I really need to add to the other side now? Okay. And instead of an 18, it's actually going to be a Negative 18. Good. So I'm going to put a negative 18 over here now. Because negative 8 times 9 over 4 would give us negative 18. So I'm actually adding negative 18 to the other side. Any questions about that step? Okay, now if we combine like terms on the left-hand side, what's that going to give us? Good, so we have y minus 21. Over here now, I'm going to keep my negative 8, and I'm going to factor what we have here. So how is this going to factor now? Okay, almost. The problem with that, we actually do want to include fractions this time because we've already factored out that negative 8, right? So we don't want any coefficient in front of the x. So we actually are going to use a negative 3 halves this time. So it's going to be x minus 3 halves squared. Remember, the easiest way to find that value that's going to go in there is to look back at your parentheses right before you squared. In this case, negative 3 over 2 didn't simplify, so that's the value we had right before we squared. That's the value that's going to go right here in our factored form now. Okay? All right, so then what's our last step? Add the 21, good. So we're going to have y equals negative 8 times x minus 3 halves squared plus 21. And this would be our function in standard or vertex form. Any questions on any of the steps for that one now? All right. Let's take a look at number 2. Okay, so we want to find quotient and remainder, and it says this time we're going to use synthetic division to do that. All right, so if we use our synthetic division here, what value are we going to put in our box? Okay, so not 5, but negative 5. Because remember, we're looking for the 0 that would come from that factor. And so if we subtract 5, we actually get negative 5. So just make sure you're using a negative 5 for your synthetic division this time. Okay, it's always the opposite of whatever that value is in that factor. Okay. Now we're going to list out our coefficients, right? So what are the coefficients going to be this time? Okay, so we have 1, 5, 2, and this time we're actually missing the constant term, right? There is no constant at the end there, so we actually do need to put a 0 in its place. Okay, so just remember, if you're ever missing a term anywhere in there, you've got to put a 0 in its place, even if that happens to be the constant. Okay, so make sure you add a 0 at the end there. All right, so now we're going to bring down that first term, and then we're going to multiply. Okay, so what's 1 times negative 5? It's going to give us negative 5. Remember, at that point, we add 5 plus -5 would give us what? That's going to be 0. Good. 0 times -5 is 0. 2 plus 0 would be what? It's going to give us 2. And then 2 times -5, -10. And if we add there, what do we get? -10. All right, so now we just want to list the quotient and the remainder here, right? So let's say the quotient, q of x. What's our quotient going to be this time? Good. So x squared plus 2. Remember, we started with x cubed this time. That means our exponent's going to go down by 1. So this is 1x squared plus 0x plus 2 is going to be our quotient, which we can just simplify to x squared plus 2. And that means our remainder is what? The -10. Good. And so this is our answer here. So I don't need to necessarily see it in the, quotient plus remainder over divisor form or anything like that. If you write it in that form, that's perfectly fine too. But since it just says find quotient and remainder, if you just list each one separately, that's fine also. Any questions on using that synthetic division to find those now? And again, the key here, don't forget if you're missing any terms, make sure you put a 0 in that place, right? Because otherwise things are not going to line up correctly. All right, number 3. You have a stone is thrown upward from the top of a building. Its height in feet above the ground after t seconds is given by the function -16t squared plus 96t plus 48. We want to know the maximum height that the stone reaches, and we're going to find it algebraically, right? So that just means don't just put it in Desmos, right? If you want to use Desmos to check yourself, that's fine, right? But we need to see the algebraic process to actually get to that maximum. So how could we find the maximum height this time? So tell me this, if we're looking for the max, what do we need to find about that equation? The vertex, right? Okay, so in this case, if we can just find the vertex of that graph, then that tells us where the maximum is, because we know we have a parabola. We know it's going to open down because it's a negative out front. And so if we can just find the vertex, then we have our max. How could we find that vertex? Okay, good. We could put it in standard form, right? That's one way to do it. So let's go that route. So we'll say y equals -16 t squared plus 96t plus 48. So we're going to use those same steps that we used on number 1, right, to get this into standard form. So what's our first step going to be? Okay, before we can factor, what do we need to do? Okay, subtract the 48, right? So we're trying to get it into standard form. We've got to complete the square. We're going to move the 48 first. We have y minus 48 equals -16t squared plus 96t. Now, what's our next step? Good. We have to bring out that -16 to get the t squared by itself. We're going to factor out a negative 16. That leaves us with t squared here. If I factor out a negative 16 from the 96t, what do we get? Good, so it's going to be a negative 6t. All right, so now we need to complete the square. So what's our b value this time? Negative 6, good. So we got negative 6 divided by 2 squared. If I simplify that now, negative 6 over 2 is negative 3. And what's negative 3 squared? Positive 9, good. That's our new c value, so I put plus 9 over here. And so what do we have to remember to do on the other side now? Okay, good. So it's going to be negative 16 times 9. And so what is negative 16 times 9? Okay, so negative 192. That's after we combine it, right? So that should just give us negative 144. And so then we can combine like terms over here, right? So the negative 144 plus the negative 48, that's where we get the negative 192, right? So we have y minus 192 equals negative 16. If we factor the t squared minus 6t plus 9 now, what do we get? Okay, good. So we're going to have t minus 3 squared. And then finally, we're just going to move that 192 back to the other side. So we have negative 16 times t minus 3 squared plus 192. Any questions just about getting it into that form? Okay, so now we want to know the maximum height. So what's our maximum height going to be then? 192, good. So our vertex itself, remember, would be positive 3, 192. But in this case, 3 would be the time, 192 would be the actual height. So our maximum height is going to be 192. Don't forget your units here, right? It said our height was measured in feet. This would be feet. Any questions on that one now? All right, so we get part B. So now we want to know, how long does it take for that stone to hit the ground? So what could I do now to figure out when it hits the ground? Good. We're looking for the x-intercept, right? Because if you think about this situation, right, it's going to be a parabola. It's going to open down, and eventually that height's going to come back to 0, which is the x-intercept. So we're going to set the entire thing equal to 0, let the height equal 0, and then solve for t because we're looking for the amount of time it takes to get there. Now, the easiest way to do this, we've already got this standard form up here. I'm going to set that one equal to 0. So this is going to be negative 16 times t minus 3 squared plus 192. Now, you could technically go all the way back to the original. You'd have to use quadratic formula because that doesn't factor. And I'll tell you that with those numbers that you started with, quadratic formula is going to get pretty nasty, right? Because the numbers are going to get really big really fast. And so that's why I'm saying it's probably easier, since we already know that standard form, just to set the standard form equal to 0 instead. Okay. Now, if I want to solve this for t, what would be our first step? Okay, move the 192, so we get negative 192 equals negative 16 times t minus 3 squared. Good. Then what? Okay, so we got to divide by the negative 16 now. What's negative 192 divided by negative 16? Okay, so we get 12 equals t minus 3 squared. Then we can do what? Take the square root. Good. We get square root of 12 equals t minus 3. And when we take that square root, we have to remember what? Plus or minus, right? So technically there's a plus or minus in front of that square root of 12 now. Right, and then we can do what? Okay, we can add the 3. So it's going to give us 3 plus or minus square root of 12 equals t. Now, the only other thing I would expect you to do here is simplify that square root if possible. So is there anything we can do to simplify the square root of 12 now? Okay, so what perfect square goes into 12? Break that down. Yeah, it's going to become 2 square root of 3, because we have 3 plus or minus the square root of 4 times 3, because 4 is a perfect square. And then we can bring out the square root of 4 as a 2. So that gives us 3 plus or minus 2 square root of 3 as our t value now. Now, just so you know, if you get to that point, I'm perfectly happy. You're going to get full credit, right? Okay, and let's look at the time here. This was in seconds, I believe. Yes, so t was in seconds. So this would be seconds. Keep in mind, though, realistically, if you were to actually do 3 minus 2 square root of 3, that's actually going to come out as a negative value, and we can't have negative values for time. So the only one that really works in this case is going to be the 3 plus 2 square root of 3 seconds. Okay, so this would really be the only answer to this one. But if you do all those other steps correctly, even if you leave the plus or minus, I'm still going to give you credit, right? Because I would rather you remember that you need it in the equation than forget it altogether, okay? Any questions on that part now? Okay. And so again, just a reminder, part A here, since we were just looking for the max, the negative b over 2a formula would also give you the x value of the vertex, and you could substitute that back in. That's another way to find it. Again, it's helpful to know the standard form here, because that makes part B a lot easier. But quadratic formula technically works in part B. You're just going to have really large values to work with. Okay? If you don't simplify the square root of 12, you will lose a point or two on this one. So try to make sure you always, if you can simplify a square root, always simplify it. Okay. Any other questions there? All right, let's take a look at number 4. So we want to find quotient and remainder, and we want to use long division this time, right? So this one you have to, right? Because we can't use synthetic on this. So I know the x squared minus x plus 3, that's going to go on the outside. So I'll go ahead and put that out here. All right, and so then what are we going to put on the inside? Good, right? So we have x to the fourth. We're missing the x cubed terms. We have a plus 0x cubed minus 2x squared plus 7x. And again, we're missing our constant. I'm going to put a plus 0 down there. Okay, so any missing terms, make sure you put a 0 in its place. Now, what's our first step in our long division now? Okay, good. We look at our first terms on the inside and outside, and we divide. X to the fourth divided by x squared is going to give us what? X squared. That goes as part of our quotient up top. And put it right here. Now we distribute, right? So we have x squared times x squared. That's x to the fourth. X squared times negative x is a negative x cubed. X squared times 3 is plus 3x squared. Right. Once we have that, then we can do what? Subtract. Good. So we're subtracting all of this. So x to the fourth minus x to the fourth, that should cancel. What's 0x cubed minus a negative x cubed? Good. It's going to become a positive x cubed. And negative 2x squared minus 3x squared. It's negative 5x squared. Good. Bring down our next term. So that's our plus 7x. And now we just repeat that process, right? So we look at our first term, the x cubed. We divide it by the first term on the outside, which is the x squared. So what's x cubed divided by x squared this time? Just x. Good. We have a positive x up here. Again, we distribute. X times x squared is x cubed. X times negative x is negative x squared. X times 3 plus 3x. Then we subtract. Our x cubes cancel out. Then we have negative 5x squared minus negative x squared. What does that give us? That's a negative 4x squared. Good. And then 7x minus 3x is going to give us what? Plus 4x. Good. Bring down the 0. And now we divide one more time because we can still divide negative 4x squared by x squared. So what is negative 4x squared divided by x squared? Negative 4. That's part of our quotient now. Distribute. Negative 4 times x squared is negative 4x squared. Negative 4 times negative x is a positive 4x. And negative 4 times 3 is a negative 12. Then we subtract again. So our negative 4x squared minus negative 4x squared, that becomes addition and cancels. What's 4x minus 4x? Yeah, that's 0. And then 0 minus a negative 12 would give us what? That's going to become positive 12. Good. Now, I can't divide 12 by x squared, so we stop right there. And so now, again, if I just want to know the quotient and the remainder, our quotient is everything up top. So that's going to be x squared plus x minus 4. And what's our remainder this time? That's going to be the 12. So this right here is our answer. Any questions on any of the steps for that long division now? Again, just like with synthetic, if you're missing any terms, don't forget those zeros, right? Because you got to have them there so everything lines up. All right. Number 5. So now we want to find all zeros and factor completely, right? So we've got this polynomial here. We want to find all its zeros and all of its factors. So what are we going to need to do first? P's and Q's, good. So let's start with our P values here. So remember, we're looking at the factors of the constant term to find P. So what are those factors going to be this time? Good. So we have plus or minus 1, plus or minus 2, and plus or minus 4, right? Because 1 times 4 is 4, 2 times 2 is 4, and we always need a plus or minus. What about the Q values this time? Just plus or minus 1, right? That's our leading coefficient. That's an understood 1 this time. The only factors of 1 are 1. So now if we divide P divided by Q, each of those divided by 1 is just going to give us the same thing we have as our list of P values. So we have plus or minus 1, plus or minus 2, and plus or minus 4. Now, once we have that list, what do we want to do next? Okay, good. So we're going to use synthetic division to check, right? But we can look at our graph just to make sure we know which ones look like they might work. Okay, so let's switch over to Desmos real quick. Take a look at our graph. So we've got y equals x to the 4th minus 2x to the 3rd minus 3x squared plus 8x minus 4. So looking at our graph now, what values look like they could work? Okay, so it looks like -2, +1, and +2. Right? And is there anything interesting about any of those? Yeah, what happens at 1? 1 bounces, which means what? Okay, it's an even multiplicity, right? So in this case, it could happen 2 times, 4 times, 6 times, whatever. We know it's an x to the 4th, so we know at most it could happen 4, and we've already got 2 other ones. So it's probably going to happen twice, right? So just kind of keep that in the back of your mind as we're going through this synthetic division now. All right, so let's switch back. All right, so now we start with a -2. It goes in our box. We look across here, we have x to the 4th, x cubed, x squared, x, and a constant. We're not missing any terms. So it's just going to be 1, -2, -3, 8, and -4. We just did the process of synthetic division not too long ago, so we'll bring down the 1. Multiply. 1 times -2 is -2. Then we add. -2 plus -2 is -4. -4 times -2 should give us +8. -3 plus 8 is a +5. 5 times a -2 is a -10. 8 plus a -10 is going to give us a -2. And a -2 times a -2 is a +4. So when we add -4 plus 4, we get 0. So what does that tell us now about -2 then? It is a 0, right? So now for my list of zeros, I know -2 works. I can put that on my list. All right, now we can go to the 1, right? So again, I'm going to continue on from where I left off here. I don't need to go back to the original coefficients. Bring down the 1. Now we have 1 times 1 is 1. -4 plus 1 is a -3. -3 times 1 is -3. 5 plus -3 should give us 2. 2 times 1 is 2. And -2 plus 2 is 0. So again, I get a remainder of 0. I know that's one of my zeros. This one checks out. So I can add that to my list of zeros. Now, at that point, it's up to you. If you want to test another one, you can. But what do we know this line down here is now? The 1, -3, 2. It's a trinomial, right? And specifically, it's what kind of trinomial? What degree? Has a degree of 2, right? So it's quadratic. So we could actually just try factoring what we have left there to get our other 2 zeros, or you could do synthetic division one more time if you prefer, right? Either way is fine. I'm going to go ahead and write the factors here and then try to factor it the rest of the way. So if -2 works, what's one of my factors going to have to be this time? X plus 2. Good. So I know my first factor, x plus 2. What's another factor going to be this time? X minus 1. Good. And then we said this is going to be quadratic, so that's x squared minus 3x plus 2 is another factor. So now I'm going to try to factor that trinomial to see if I can find my last 2 zeros. X plus 2, x minus 1. And then what factors would give us x squared minus 3x plus 2? Good. X minus 1 and x minus 2. Right? Because -2 times -1 would give us the positive 2. A -1x and a -2x would give us the -3x in the middle. And so then the only other thing you could do here, since we have that x minus 1 that repeats, you could rewrite that as squared, right? So I could say this is x plus 2 times x minus 1 squared times x minus 2. That would be my factored form now. And then the zeros that would come from those last 2 factors would be what? So from the x minus 1 and the x minus 2, what would those zeros be? Okay, good, right? So we get positive 1, positive 2. So in our list of zeros now, just make sure, right, because it's asking for both the zeros and the factors. So this would be our complete list of zeros, and this over here will be our complete factorization. Okay? Yes, right. So if you wanted to go ahead and just do the synthetic division on 2, and then whatever you get as that last factor, right, then you would just include it. As long as you end up with all the zeros and the complete factorization, that's what I'm looking for here. But I do need to see at least the synthetic division test. But whether you factor that quadratic or do synthetic division one more time, it doesn't matter to me. Okay. Any other questions on that one? And just so you know, also for this one right here, I either need you to tell me that it's a double root, right, or has a multiplicity of 2, or you can list it twice, right? So I need to see that you understand that there should be 4 zeros for this one because the degree is 4. So make sure you show me somehow that there are actually 4 zeros to this one, okay? So either list it twice or tell me it has a multiplicity of 2 somehow. All right, let's take a look at number 6. All right, so same thing. We want to find all the zeros and we want to factor completely. So we can go through that same process again. Let's start with our p-values. So what are the p-values going to be this time? Okay, good. So plus or minus 1 and plus or minus 2, because we're looking at that constant, which is 2. Only factors of 2 are 1 and 2. What about the q values here? Just plus or minus 1, because that leading coefficient is a 1 this time. So when we do p over q, again, it's just the p's over the q, so that's plus or minus 1 and plus or minus 2. All right, now I'm going to go to my graph just so we can see which ones might actually work, which ones we want to test. All right, so we've got x to the 5th plus 3x to the 4th plus 3x cubed minus x squared minus 4x minus 2. All right, so what zeros might we want to check this time? Okay, so it looks like -1 and +1. And then what do we know about the -1 here? Even multiplicity, right? So keep in mind here that -1 could happen multiple times. And so we might have to check it more than once. Okay, so just keep that in mind when we do our synthetic division now. All right, so let's go back. All right, so I'm just going to start with -1 here. So we'll do -1. We look at our coefficients. I'm not missing any terms. So it's going to be 1, 3, 3, -1, -4, -2. And so just for the sake of time, I'm going to go through this, bring down the 1. 1 times -1, -1. Then we add. 3 plus -1 is 2. 2 times -1 is -2. 3 plus -2 is 1. 1 times -1, -1. -1 plus -1 is -2. -2 times -1 is 2. -4 plus 2 should give us a -2. -2 times -1 is a +2. And then those cancel out and give us 0. So that tells us now that -1 is one of our zeros for sure. So now we're only down to x to the 4th at that point, right? Because we started with x to the 5th. We've done our synthetic division once. We already said that it looks like -1 might have an even multiplicity, right? Since we started with x to the 5th, we need to do synthetic division at least 3 times, even to get it down to a quadratic that might be able to factor or use quadratic formula, right? So I'm going to go ahead and test the -1 again, since I know I need to find at least 3 zeros that work. So I'm just going to do -1 one more time here. So we bring down the 1. 1 times -1 is -1. 2 plus -1 is 1. 1 times -1 is -1. It's going to give us 0. 0 times -1 is 0. -2 plus 0 is -2. -2 times -1 is 2. And that gives us a remainder of 0 now. Right, so -1 does work again. And so again, either list it twice or just tell me that it has a multiplicity of 2 now. Right, now, I can test the 1 at that point, because I know if I do this one, then I'll be down to a quadratic, and then we can see what we can do with that. So bring down the 1 again. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Remainder of 0. That checks out. So I have those 3 zeros. Any questions up to that point? Because I know I kind of went through that quickly. I'm trying to make sure we have time to finish this one up. All right, so let's think about the factored form that we have at this point. I know -1 worked twice, right? So that's going to be x plus 1 squared. And then I know my 1 worked, which is going to give me a factor of x minus 1. And then we can look at this line down here. Remember, we started with x to the 5th. We've divided out 3 times now. So we're down to x squared plus 2x plus 2. So that's what that remaining line would be this time. Now, can we factor x squared plus 2x plus 2? No, right? There's no factors of 2 that when we add them together will give us that 2x that we need in the middle. So what are we going to have to do this time? Quadratic formula, right? So we can't do synthetic division because that's none of these are going to be rational, right? So we're only going to get irrational values out of this. So we have to use that quadratic formula to actually find the remaining 2 zeros this time. So we're going to say x equals, then we have negative b, so that's -2, plus or minus the square root of b squared, which is 2 squared, minus 4ac, so that's 4 times 1 times 2, all over 2a, which is 2 times 1. So if you ever get down to a quadratic that does not factor, the only way we have to find those last 2 zeros now is to use our quadratic formula. Okay, so make sure you remember quadratic formula. And now we're going to simplify this. We have -2 plus or minus the square root. 2 squared is 4. -4 times 1 times 2 is a -8. And all of that is over 2 times 1, which is 2. So what are we going to get inside of our square root this time? A -4, right? So we have -2 plus or minus the square root of -4 all over 2. Well, what's the square root of -4? It's a 2i. Good. So we get -2 plus or minus 2i all over 2. And remember, as long as you can divide everything by what's in the denominator, go ahead and do that. So -2 over 2 is -1, plus or minus 2i over 2 is just I. So now our last 2 zeros are going to be -1 plus I and -1 minus I. There's our list of all 5 zeros. And honestly, if you get to this point with your factors, I'm good, because you've got it down to linear and irreducible quadratic factors at that point. Or if you want to use the -1 plus I and the -1 minus I and write those last 2 factors, you could do that too, right? But this right here would be perfectly acceptable so long as you find all the zeros and you at least get it down to linear and irreducible quadratic factors. I'm okay with that factored form. Okay? Okay, so I know we're out of time. I will hang out for a couple more minutes if you got any questions. I know we didn't get to number 7. We might be able to start with that one right after the break before we jump into the next unit, just so you at least see how to work through that one before I post the test. But just know that the solutions are posted in Blackboard, right? So if you want to go ahead and start looking at that, do that. Send me questions over the break if you have them. But have a nice break, and I won't see you again until next Wednesday. So try to enjoy it. Take some time to yourself. And then we'll get started back up on Wednesday of next week. See you then.